All right. Good morning, good evening, everybody. I am here, Sebastian Maniak. I'm joined with Nathan Pierce from Solo, and today we're gonna have a conversation about really moving your agents into production. Right? We have been focusing a lot, probably in the last couple years, on models. Right? Everybody's questioning, what model you use, Opus, Fable, GPT. I think that question has been really solved. Uh, the question where arises a lot, I find, is now what do we do with all these agents? We started with prompt engineering, with harnesses, loop engineering. Now we got graph engineering all together, which to me really is just all about workflows itself. But the good news is I feel like the model question has been solved. Um, and the bad news could be that the agent question isn't really. How do we run these things itself? Let me just share before I do that. Nathan, do you want to introduce yourself
Yeah,
to?
hi. I'm Nathan. I'm lucky enough to work in the same department as Sebastian here, and yeah, excited to join this chat because it's such a volatile space. It changes so frequently. We are fortunate enough to be right in the thick of that in every single change, so hopefully we can share some cool stuff with you, and a lot of our learnings might save you going down some interesting rabbit holes that you didn't need to go down.
No, perfect. So I'm just going to set the stage here itself. And like I mentioned, I feel like the model question has been solved, and now it's kind of this agent question, right? It isn't. Um, and I've spent most of my time here at Solo, and even before that, teaching AI and working with a lot of the AI tools and applications that platform teams are now somewhere between this. The pilot worked, and we can't get this into production now, right? And that's changed probably in the last 18 months, is that the thing everyone was worried about turns out not to be the thing that blocks them, right? People are worried about these models, but I don't feel like that's blocking them again itself. Because 2 years ago, the hard part was getting a capable model in your environment, right? So if you had strict data requirements, you faced, a genuine compromises, you had to adopt a specific frontier AI model, or you had to protect your data, right? Pick one of these, right? There was a constant, or like a real constraint, and it stopped a lot of serious programmers or programs going forward, right? But I feel like that's over. The frontier models now run wherever you need them, right? They could be managed, they could be inside your own cloud, inside your own hardware, in environments that can be, well, that are never touched in a public internet, so they can be isolated, and they're really fully capable. They have long context, right? Native multimodal systems, the whole thing, right? Against the data that can never leave itself. So the compromise between capabilities and control, I feel like it's finished. It's just now that if that's the problem your organization has been circling, you got to stop circling it, and it's behind us, I find. We have the models, pick how you're going to deploy it itself. And here's what kind of happened is that the moment it was that nobody stopped at the prompts and chat windows, right? We're not stopping just prompts and chats, right? Organizations that solved the model questions immediately started building agents, right? Software that reasons over confidential data, calls tools, coordinates with other agents, and acts on systems that actually matter, right? And this isn't a handful of pioneers, right? I think this is from FinOps. I got this stat from the FinOps Foundation that 98% of FinOps teams now manage AI spend, right? 2 years ago, that was 31%, right? And that's the FinOps Foundation State of FinOps 2026 document. You can kind of Google it, you can find it itself. So when your finance organization has had to build a practice around something, right? We are well past experimental thing, I feel like it itself. Which really brings me to, the thing I mostly want to talk to about today. And really every question you already answered for models comes back at the agent layer itself. Right? Where do they run? What can they reach? Who govern those tools? And how is any of this audible, right? What do you think? Like, are these the questions? Is there other questions you think, Nathan, that we could be asking now as we start deploying agents into production? Or
I mean,
like, I feel
honestly,
like this makes sense.
I think anyone who went through that wonderful journey of breaking up the monoliths into microservices has probably got some PTSD around, oh
Yeah.
wow, okay, I can make it into a container, but can I put that in prod? It was the same kind of patterns, right? That people went through there that we're facing again with um with agents, but agents are a little bit more like an octopus to control because
Mhm.
they're evolving and doing things more than a self-contained little container used to do. So yeah, I'm curious if anyone has any questions that we missed, jump in with them because
Yeah.
there must have been some great lessons learned on that path, right?
100%. And I feel like the same stuff that we focused on in microservices, when we're moving finally from it works on my laptop to production, really follows, these six uh kind of life or these 6 points itself, life cycle, right? Create, versioning, deploy, how to retire agents, right? We've done that with microservices itself. Model connectivity now, right? We can consume many models, we can manage them, we can run locally. I run a multitude of models. I have the frontier models, Sonnet, Opus, GPT, Grok. I use them for different things, right? Yeah,
All
I
of the
even use
models.
Grok. Man, I actually I'm a big fan of Grok build because of how customizable it is. But I have local models. So if I've built specific agents, I have probably about 13 different agents running in my house that do probably like seven of them are work related. The other ones are all personal related. And I personally had to go through this kind of process of understanding how to productionize my own agents now because I've probably built it like 15 or 16 times my environment because eventually something dies, something breaks, started with OpenClaw, Hermes dies, Hermes breaks, I have my agents. And then I've built now specific agents for literally specific workflows. I have an agent that opens my garage door. Like I literally, it monitors when my garage door was open. And I can open it from Telegram, my phone, send a voice message. I can even open it from my e-ink if you've seen kind of any of those videos. Uh,
Have you ever had your garage door open and close in the middle of the night, though? Does that agent ever hallucinate and start doing
no,
wacky
it
things?
hasn't. It hasn't because it has rules in it. I actually have guardrails when it can't open things itself.
Nice. I mean,
The
for
one thing
me,
I'm
the two big ones here are like to me, the identity and the observability, because identity with an agent, I mean, it's not logging in like a person. It might use your credentials and log in like a person, but like it needs to have its own identity. And the observability, the communication path is so different from anything we've seen before. These things work in loops, they iterate, and they have context. It's not like in the days of microservices where there was a clear path through a mesh, like an upstream
Mhm.
and a downstream, and that was pretty simple. But no, agents don't operate in that kind of same stream, and they carry context, and you can't just fail it over and nuke a context midstream because you're going to lose everything that was important to what that agent was doing. And so you need that traceability, but traceability on something that's getting info here, that's checking something there, that's then operating on all the context that just pulled together. Yeah, tracing was the big one that I remember before joining Solo. I kept just thinking, how are we solving that problem? That seemed like a scary one to me, which was a delight to see when we had
I
solutions.
f I feel like those are the two things that um we talk the most about with customers. Lifecycle,
Yeah.
they're pretty good at doing GitOps and that stuff is fantastic. Models, we've been running chatbots so people understand their models, I find. But you're right, it's identity and observability. Like, and it keeps on like ID Jag, right? Just came out, right? That's there. Um,
So evolving fast, right? And
it's moving so fast,
it
right?
suddenly becomes very important when just one afternoon you see your month's token spend
Yeah.
halve, and it's like, How do I work out what just happened there? Because I mean, guardrails are great, but again, that is an
Mhm.
evolving space as well. Because the models evolve so quickly, you're having to continue to evolve to like, well, what could it do next? Like now I've got to add skills. Now I've got connections off to third-party things, and yeah, it's tricky getting that. That to me is that's the scary part of going to production with an agent that you need to have solved.
In your like home lab environment, do you
Have
um
nightmares about
track
agents going
oh
wild?
yeah,
Yeah.
well, yeah, agents can go wild. I've had what did I had some agents that would log into my Proxmox and turn stuff off by accident. But that was like by design. I wanted to see if it will do it because I wanted to add guardrails and stuff to it. But I'm almost done building this little other side project where I have a terminal screen where it just tells me my token spend. So I'm feeding all my tokens through kind of Agent Gateway into the actual platform, and I just want to see my tokens. Just like I want a little widget that just tells me every time my tokens are being used itself.
Cool.
It more from a me perspective than anything else.
That is cool. So when you're out for dinner with the family, you can get a notification, hey, you
Yeah.
just lost 2 million tokens just disappeared. What did you do?
Oh yeah.
I love
Um,
that. That's so
so
cool.
uh and we touched based on this, and I just put this in here that all those questions are all also microservice focused that we've been dealing for a decade, right? Decade ago. Life cycle, discovery, identity, policy, observability. It's really the foundations you run things on, right? And the agentic era needs, I feel like, the same operating model extended to agents itself. Um, so the question isn't whether, to buy a new platform for agents, or it's whether the one you already run learns to treat agents as things. It understands itself. So what I've put together is kind of this four pieces of a single operating model or one operating model that focuses on agent substrates, and we'll dive into what this is next, which is really a runtime foundation. It's how agents actually are executed on Kubernetes. K-agent, which is what makes agents kind of a first-class Kubernetes citizen. Agent registry is a catalog. So agents, tools, versioning, the owner metadata. Think of it like your AI catalog uh, of all the AI artifacts you need. And then agent gateways, that data plane for every kind of agentic traffic. So you can, uh, route, govern, and add policies to all these things itself. That's how I'm kind of seeing a lot of our conversations. And this could be, of course, deployed in one cluster. It doesn't have to be in a SaaS. It could be deployed anywhere you want. Uh, or it can have, of course, AI and sovereignty is a big thing right now, right? You can take this approach
Mhm.
and deploy it in your own environment, in your own GDC, Google kind of cluster, probably an Azure cluster, local on-prem, whatever you want itself, right? Itself. So if we start at the bottom with just kind of helping identify what an agent substrate is, because I feel like this is going to get hotter and hotter as we
Mm.
move things into production, because this is the pieces people skip and then regret later on. I've done thousands of deployments of agents in my home lab, and I'm like, oh, I wish I would have done it better. I wish I would have done it that way. Um, so agents are long-lived, right? They're stateful, um, and they're idle much of the time, right? I've had conversations with customers who are like, yeah, our agents are just sitting there doing nothing. They're taking resources, right? So think about the shape, um, right? An agent might sit for 20 minutes, holding its context, waiting on a human, then do 4 seconds of work, right? A traditional Kubernetes workloads aren't shaped like that at all, right? They're a request response, stateless, and you scale them to zero when nobody's calling. So if you run an agent as an ordinary pod, you pay kind of that idle capacity, right? And it scales with the agent count times and the agent lifetimes. So going from a pilot to hundreds of agents in production, it's a very unpleasant curve.
It's
It's
horribly inefficient
it's
and expensive.
horribly inefficient, right? So
Not that we're hating on Kubernetes. It's just when it
no,
was designed, this workload wasn't in mind.
Yeah.
Yeah.
So 100% it wasn't. And what Agent Substrate is what, a couple weeks, 2, 3 months old.
So shiny
Right,
new, but
right.
so cool.
Which is phenomenal how fast it's moving, how fast the community, that open source community is kind of just pushing through. They're like, oh, we understood all the stuff we did with microservices. Now we understand, how can we do this better? So when we do eventually move stuff into production, we're not going to regret it and spend all these resources on space itself, right? Because the agent substrate is that kind of that runtime model built for this type of shape, right? Execution density, isolation, sandboxing, real lifetime manage or real life cycle management itself. So Solo itself with Google have been building this for the past couple of months, which kind of makes Kubernetes genuinely a first class agentic platform rather than a place you can technically run agents, I find itself.
Yeah, the economies of scale here, the efficiency with Substrate, just that it's built on micro VMs, so it's the same principle as how like serverless platforms are built. So it
Hmm.
might have a 100 to 200 millisecond boot time, which can be a little bit to wait for, but that's the whole point. You have them warm and running because the snapshot, the suspend and restore time is typically in the sub 5 millisecond span. So
Yeah.
you can have massively oversubscribed platform now with these agents ready to go, with their state preserved that shut down, and then the moment you want to interact with them, sub 5 milliseconds, they're back up, processing your demand, and then going back into that suspended state where they're freeing up the CPU and RAM that they were holding onto. So it's pretty awesome. You're effectively turning Kubernetes into this agentic serverless
Mhm.
platform that is not doing any waste. I'm sorry if it's probably coming across. I'm so excited about
No,
Substrate and
I think it,
K-Agent together is like the coolest thing. It's like
yeah.
the Hulk and Thor of the MCU universe. Like,
And what's what I really love about it is like already this was like so when I first started like at Solo like 10 months ago, I built the workflow of my orchestrator agent, and then was talking to my FortiGate agent, my Kubernetes agent,
mhm.
my F5 agent, and all these agents were running, always on, taking resources. And I have compute in my home lab, but I don't have that much compute in my home lab to run everything
Yeah.
itself. So now I migrated everything to substrates where now if I ask my team lead, I call it a team lead agent. I'm like, hey, you're the team lead. Go find out what my F5 VIP is configured at, or go find what my VPN is. Actually, the number one thing I ask is uh, shut down YouTube on my Samsung TVs. That's the number one thing I ask my agents. And I wanted to make it very easy. So, me, my wife, anybody can do it. Uh, when my kids want to have YouTube or want to go on YouTube, I just want to be able to go, hey, Google, or I do have a voice thing now. Of course, I called it Jarvis because that's the
You
default.
have to.
You
It's the
have
law.
to.
Yeah.
And I'm like, hey, shut down YouTube. And the whole house, it literally, the team lead talks to my FortiGate firewall, applies the policy to that specific device, and shuts down YouTube right away. And it
That's
could
so
turn it
cool.
on if I want to watch something for a specific. I'm like, hey, Office TV, turn on YouTube, right? A couple seconds and turns off, and I could see them spinning up and down.
That's
Um,
so cool.
but that's a use case for myself, right? In production, you're going to be doing more things, right? And you're going to, like we just mentioned, run this on top of K-Agent. And just to uh, kind of introduce what K-Agent is, it's um, it well, K-Agent is really a Kubernetes native controller that extends your platform team and lets you operate agents through GitOps, RBAC, provide human in the loop, have that end-to-end tracing so you know who and what and all these agents are talking to, right? It's a declarative way for all those tools to be using the Kubernetes resources itself. And that human in the loop is one of my favorite features. Like I have it linked up because for actions above a specific threshold that I can define, the agent stops and asks. So when the agent stops and I'm running an agent substrate, it's not running. It's shut down until I answer. Then it will spin up the agent and then execute the task. Right. So allowing my resources to be right not maxed to the point itself.
And
Um,
in that one sentence there, you just ticked off all the things I explained at the beginning that were the things I was terrified of about getting agents to prod. I mean, you got the
mhm.
visibility there. You've got the efficiency. You're not just got heating your office up with agents that are doing nothing all day long. And then you've got that human loop and the traceability. All of those things together, like you just took all the scary stuff out of that entire
Yeah.
platform. Yeah, so cool.
Heating my office is the hardest thing. I face the sun all morning. I have a fan on me because I have
Already at
a
9 a.m., you're trying to cool
already
off.
at 9 a.m. I have a big 5080 desk PC right on the right hand side of me right here. And it's hard to see, but I have like a DGX Spark and I have little kind of Intel Nooks all along the side, kind of hidden. It's a little dark. Uh, and they can make a little noise, right? They can go boom, right?
Yeah.
So here's I just wanted to kind of a quick visual of K
Mm.
Agent dashboard where you're able to kind of see stats of traces, just so you kind of have a visual itself. But you could definitely, if you hit up kagent.dev, you'll be able to get this. You'll be able to get started pretty quickly, actually, in a kind cluster and inside of a Docker, very
I
fast.
remember first joining and looking at a trace in K-Agent and just seeing it go through an entire agentic loop and showing all the back and forth and everything. And I remember taking a screenshot of it and sending it to you and Matt, and
Oh,
just with the word "wow." Like
yeah.
that solved such a big problem.
So now that we kind of talked about agent substrate, K agent as a runtime or managing Kubernetes native controller, right? Extending that in. Um, I wanted to kind of quickly dive into agent registry, right? And agent registry answers this tool question, right? You have a one curated catalog for agents and tool servers that are versioned and owned, and agents declare which tool servers depends on, right? So the dependency graph is explicit, right? Rather than something you reconstruct, right? When the security team asks, you already have it, right? The second order effect worth naming is that because it's a speed benefit rather than a kind of governance one, once you've built something and you've cataloged it, right, it's discoverable, right? The integration or really the integration one team builds kind of stops that team's private plumbing and becomes a building block anyone can pull. I know, Nathan, you've dealt with this, and I've dealt with this for so many years. If you're managing an organization and I'm the networking guy, or I'm the security team, I'm the platform team, I'm the server team, we're all building our own bash scripts many years ago to do the same thing.
Hmm.
Even within the team, I've had tons of people, oh, I've done this script, oh, I've done that script. I'm like, that's great. All the scripts do the same thing, right? They just have different, right, number of lines of code. And we're doing the same thing with agents. I'm seeing customers, one team builds an MCP server, another team builds the same type of MCP server, maybe a little bit, a couple different tools, less or more in it. They do the same thing. They have an agent. I've seen a security team build an agent for their load balancer to pull data. And I've seen the networking team build the same agent to pull load balancer data, just like they do for the platform teams and for their Kubernetes environment or Helm or Cilium or whatever it is. They're all building their own agents because they can run them locally on their laptop in a Docker and this kind of uh, way to solve their specific problem. What Agent Registry does is centralizes that all. So it gives you that catalog that then you can now take that skill, that agent, that MCP server that works, is versioned, has metadata, uh, and then eventually you're evaluating it in a single tool, and then you can kind of curate it and move it wherever you want. Now deploy this agent into K-agent, or deploy this agent into Agent Core, or Vertex, or whatever Google's calling it now itself, right? So it gives us that capability or that mechanism behind the sprawl, right?
And with an approval model built in, wrapped in a nice
Yeah.
RBAC that allows, so people can submit agents,
Hmm.
but not go all in. You can have that approval step of what gets published and
Yeah.
what version sort of updated. But yeah, that central catalog, like you said, I mean, I have so many things running locally. Have always done that. You and I, like, we came through the
Oh,
networking and security industry through the whole DevOps and platform ops
yeah.
evolution, and so much bash just everywhere all over
Oh,
the place. And agents
nonstop.
are doing the same thing. It's following the same path.
You just take a little bit more resources, so now you need to think
Yeah.
better on how they're running. All right. And here's kind of just a clip from the UI. As you can see, we can have a catalog of all the different types of AI artifacts that are built that could be shared. We can have different connected runtimes, be it Foundry, AWS, K-Agent, inside the environment. So you have a central view, not only from consuming it, but from an executive perspective or CFO. You can see, hey, which environment are we using the most or tokens from, or the most agents are being called from. What is the most critical one? We can kind of have that visibility, and we can also send that data to your specific OTel or your specific observability tool itself, right? Now, I think the most important piece is kind of this control and data plane, right? That I think it's the most important part because uh, it really follows, or well, there's exactly like I say, three traffic patterns that define an agentic system: agent to model, agent to tool, agent to agent itself, right? And the third one is where, sometimes people forget agent to agent, and it's one that grows the fastest. The moment you have more than a couple of agents, right? They start calling each other. And the traffic is very bit as consequential as the model calling, because it's how work actually gets delegated across your estate. And that's really the workflow itself. Back in the day, we're always talking about workflows, Ansible workflow, Terraform. It's the same thing, right? So the moment that you recognize that, hey, I need to understand also agent to agent becomes your highest trust traffic. So one agent is instructing another to act. And if that hop isn't authenticated and authorized, right, you have built this lateral movement path straight from your estate, right? And you've built it on purpose, right? So you need to have an agent gateway to be able to proxy enforce, right? Have an enforcement point on observability, on what kind of traffic gets routed, how is it routed, what tools it has access to be able to have all these kind of patterns and data being sent to the back end itself.
Absolutely. And so, sorry if I'm jumping ahead here, but I'm a big fan also of the standalone version that we released because I
Hmm.
mean, great, it's critical to have Agent Gateway sitting in front of your agents that are talking out to providers, to frontier models, to MCP servers hosted out there. But also, I mean, just people coding at their own machine, like running, building prototypes locally,
Yeah.
etc. How can I keep visibility on that? My spend, like, how can I provide some guardrails because we're working in a regulated industry maybe, and I'm not allowed to just do what I want all day long. The fact that you can also now run this as a standalone outside of Kubernetes because everybody's now writing code. Everybody's got Claude
Hmm.
Code at their disposal and is vibe coding solutions in their organization. So I think it's super cool that this actually is available in both deployment models.
Yeah, you could use it to test the models and the agents, right? Spin it up. All right, run Claude Code, run Grok build, do the same prompt, build the same agent, execute it through my local agent proxy. or agent gateway proxy. And all right, give me the stats. All right, here's how much it cost. Here's how much it spent. Here's the input output, cache reads and writes. I just want to see this because if I move it to production, I need to know this stuff.
Yeah.
Like especially like you mentioned, finance,
I
insurance,
do it, run
government.
it myself. You can just point
Yeah.
like you can define a
Hmm.
proxy, an upstream proxy in Claude Code, and Agent Gateway. I think it uses like 20 mega RAM. It's so lightweight and efficient.
Yeah.
It's
Oh,
nuts.
huge.
Like built from the ground up in Rust,
Hmm.
and it's crazy light and efficient. And so I just use it for myself to see like what did I just run in this session because all you get back is like what percent you've used of your budget before you get shut down. That's the whole insight I get from, the providers. Whereas if I'm running this, I can see, what I'm sending to what model. Yeah, like you're showing right here, I get all this visibility from my own local experience. So
Yeah.
it's not a surprise when I throw that into a Kubernetes cluster because I've seen what it's doing and how it's behaving on my machine. And so to get that same experience I'm going to get when I drop it into Kubernetes from my initial prototyping in my own little machine, then yeah, that's super powerful and super handy.
Yeah. And it's just a safe way to move forward when you're going to be deploying anything agentic. And as things change, right? Like the biggest thing, yesterday, right? MCP uh, was
Yeah.
released. MCP stateless, statefulness. I forgot what the number is. I wrote probably like 17 posts about it, but I forgot what the actual but MCP was updated, right? And now we've been building MCP for a year. Now we got to re-architect it. We got to test it. We got to validate it. How easy it is now to just, hey, let's spin up Agent Gateway. It already supports it, right? Let's pump out our MCP servers. This is another question. Do you think we'll see, because you have a big load balancing background, um, the, or I guess we have the concept of if we deploy MCP servers on whatever runtime, we're going to have to keep those MCP servers highly available itself, right? So now with statefulness, that kind of helps us that we
Mhm.
don't have to have some type of load balancer in the front to do it. Um, but I was trying to think, will we have any issues with that? No, because now the
Yeah.
statefulness is on that device. So if I'm load balancing you back to that same MCP server, you shouldn't have an issue then.
Yeah, I mean the way persistence works is going to change. It's a lot friendlier to traditional kind of proxies and gateways because in the spec prior to July 28, it was literally just yesterday when the new spec dropped. But the previous one, you had to find the MCP session ID inside that gRPC payload. So you couldn't just scrape the headers like most proxies do. You couldn't just grab a cookie or look for an identity in a header. You had to fully parse that payload and understand it and track state across the communication. So that's what made it stateful. You had to be locking that session ID to that server because any other server is going to say, I don't know who you are or why you're giving that to me and drop it. And so with that gone, with that no longer a requirement, there's no MCP session ID inside that payload, then actually there's two other parts. They've moved two headers in, they've moved two bits of information, what the tool's doing, like its function, into the header to make it a lot easier for many gateways and proxies to just scan the header and be like, oh, this is a tool call, we should send it over there, or this isn't a tool call, so we're going to send it this way.
Mhm.
But the problem is, I don't want context. It all comes back to context. This is the new nightmare we have to solve um, with anything with agents is if I suddenly move something and all my context is lost in that communication, I've lost all of the value of that. And I don't want to just be like look at it from an authorization perspective. What if I don't want to be pulling the entire state of
Mhm.
all of these MCP servers back and forth in every communication, which is going to give me context bloat? I just want to say, you know what? Only these three, and just give me the front matter, the way skills load. It just gives you the front matter, a little bit of information so that when you do need them, you'll make that call. So you're not preloading all of that context into the window. And the only way you can do that kind of authorization model is if you're fully parsing the MCP
Yeah.
payload. You've got to be looking at the full gRPC and saying, actually, we don't want all of these tools. We have just authorized these three tools of the 200 across those MCP servers. Just include those three in. You cannot add any of that critical value. You cannot enrich MCP unless you're fully parsing it. So I think we're going to see a lot of proxies saying, now that the state's been removed from the payload, that session ID, a lot are going to say, oh, we support MCP now. Support, what they really mean is we don't break it anymore, but we don't enrich it either until you are fully parsing MCP and actually adding some value there, like the authorization, the authent example I just gave there, where I can say what's inside that payload going to my users. Until that's happening, I mean, okay, big deal that you don't break MCP anymore. Sorry, a bit of rant
Yeah.
from me. I've got a couple
But
decades of
I
proxy
that's super
experience.
important to note, right?
Yeah,
Because as platform engineers and AI engineers and forward deploy engineers are now building the next version of their MCP servers, they need to understand that critical point, and they'll figure it out a couple months in, a couple weeks in of developing, like, oh shoot, you know, now I know. But it's good for them to have that, right?
yeah,
So I know this is only like an hour webinar. I don't want to talk for more than 50 minutes, to be honest, but I want to circle back to those six questions or those six kind of bullet points um, that talk about really the life cycle, model connectivity, tool identity, and how we map all these open source tools itself. With life cycle is K-agent, having that declarative agents, GitOps, RBAC consent, model connectivity, having that agent gateway for that one interface across every provider. Tools, right? Cataloging, using agent registry and agent gateway, right? To catalog them and authorize them. Identity, agent gateway itself does that app establishes enforcements, and then where that observability and communication goes through K-agent and agent gateway for tracing, and underneath using agent substrates, which we don't have a logo in, so I have a little diamond in there for it. But how we can effectively run all these agents inside of a Kubernetes environment to kind of utilize these life cycles. So when you are building production or moving from kind of your pilot to production, I think it's critical to think of these kind of six things on how do we solve it? How do we look at all these six things and how are we going to solve it itself? And the best way to start, like we've been mentioning, is with open source. All right. K-agent is part of CNCF. Agent Gateway is part of the agent double A agent AI foundations, like double AIF. I've been practicing double AIF and I like it. Double
and it's
AIF.
the only gateway in the
It is the only
AI
gateway. Yes, yeah.
alongside heavy hitters like Claude, OpenAI. Like there's some
Yeah.
big stuff in there, and us.
So this is literally that call to action is the best way to start is with open source. I find it's open source tools. I've grew up on open source tools, use them, to my advantage, and then grow from there. Grow that pilot to a production type environment or an enterprise type environment itself. And then when you're in conversations with your team, I've put together maybe four questions as you're building it. It is when an agent acts on behalf of a user, whose identity reaches the tool? I think it's an important question, right? How many tool servers do you run? And, what can each one reach? And if an agent spends, double tomorrow, what stops it, right? Or, could we produce an audit trail of what the agent did last week? These are like four simple questions that I always, when I'm having conversations with customers as they're on this journey, I ask them these questions. And then they're figuring out, oh, these are actually, this is how I have to figure out. I have to think about, a gateway, a proxy. I have to think about Entra, Auth0.
Oh,
Who's going
yeah.
to be using it? What's the workflow? I don't know if you have any other questions that you could add to this. I don't want to put you on the spot, but I feel like these are like kind of the basic fours that we need to kind of focus on.
I mean, that first one's big. I mean, token exchange is a gnarly
Huge.
one that grabs a lot of people. Like you don't you've got your local federation going on. You're logged in to your local provider and you've got your local identity, but that means nothing to that MCP you've got to hit
Hmm.
um out somewhere else that's got its own identity. You don't want to be having a gateway that just stores that because then, well, hang on, I'm hitting a MCP endpoint that's fronting 10 different MCP servers. So how's it going to juggle all the different upstream? Like that is a gnarly problem to try and
Yeah.
solve. And it's the kind of thing we solved in Agent Gateway. Like, how do I do that token exchange in a nice, safe way where me as the developer or my agent that is running only needs to have its identity and its communication to Agent Gateway, and Agent Gateway is actually storing those upstreams and
Hmm.
swapping them out in real time for whatever it's talking to, and handling token refresh for you as well, like that. But trying to solve that one in code, like don't waste the cycles. Like
Yeah.
you want to be using what we've delivered for token exchange.
So as a next step, what I recommend, and what you could do to kind of get started or identify how you're going to move some of these agents, we actually have two webinars or two workshops. One that's already on demand. We did this last 2 weeks ago. Nathan and Michael Levon and I is we have an on-demand workshop that gives you access to full K-agent agent substrate that allows you to build them so you can see it in action itself and kind of understand what we're talking about when running agent substrates within Kubernetes and that whole uh, life cycle process of building agents. And then we have an upcoming one, August 4th, uh, the update the MCP stack. So the updated MCP spec, the good, the bad, and the ugly, with I think Christian Posta and Aton and Lynn are running this one, and they'll be informing you and giving you a workshop on what's changed and what's moving forward, and how you can enhance your existing MCP servers and tools to meet the new standards itself. Um, with that, I just wanted to, if you have any other questions, if not, we really appreciate your time joining us today. This will be recorded. We're going to be posting it probably on YouTube and LinkedIn and all the other social media channels. But I really appreciate Nathan jumping on this morning at was it 4 a.m. for you or 2 a.m.? The sun's
It
coming out.
was about 5:50. Beautiful sunrise going on right now
Beautiful.
in California, so the sun's just
Oh,
coming up.
amazing. It's going to start snowing here in Canada soon, so I'm jealous. But with that, thank you everybody, and we'll see you at the next one.